We have seen containment thoroughly, means there are many kind of containment, and the kind of the containment that is to ponder about is mainly composition, aggregation, and delegation. So, three form of containment, that is kind of it is a pillar stone in designing. But if we see the designing, there the main reason why we design is reusability. When we write the code, so we strictly follow that whatever we do, it should be closed for modification and open for extensibility. So whatever code we write, it should be the final code. Means we should not modify it. If that is the case, then reusability comes into the picture. So how we can kind of reuse the piece of code that we have written. So one is containment and another is inheritance. So inheritance will see various possibilities in inheritance. So inheritance is like if class B inherits class A, then class A comes inside class B. So it is as good as whatever the code is written in class A is actually part of class B. So if class A has function func1 and func2, then func1 and func2 to the client who is using B, func1 and func2 belongs to class B. So class B inherits A and A has function func1 and func2. Then B has func1 and func2 from the external perspective. So this is the how we do the usability, but we have nothing written separately for this. So this is inheritance. So whatever is in parent, that is kind of automatically comes into the children. Okay, this is not the parent-child relationship that we see in graphics. Parent-child relationship is containment, and that is completely different. So inheritance is not the parent and child. Inheritance is rather, we can say, it is base and derived class. So derived class inherits base class and all its attributes and operations. It becomes derived class attribute and operation as far as external world is concerned. So no need to write. So that is the so first we see how many kind of inheritance that we can do. One is normal inheritance. So the what we are talking. So all the attributes of base class and operations comes inside the derived class. So that is one. So that we also say a kind of extending generalization. So the derived class generalize or extend the base class. So whatever there in the base class comes into the derived class and then it can extend more. So this is one inheritance. Other is suppose the base class is an interface. Interface can be canonical notation also means rectangle or it can be round shape also. Okay, called lollipop. Okay, so it can be a kind of rectangular shape or it can be canonical form. So it can be in both way. It can be represented the interface. So if it is in round shape, then it is an interface. Interface in the sense that it has pure virtual methods and it cannot be instantiated. So an interface class must be implemented. Okay, so if we need to implement an interface, we need to derive from it, and all the pure virtual we have to write. So either we can implement or we can realize. So we can realize an interface in the some concrete class deriving from it, and there we provide the kind of code to the pure virtual. So we talked about extensibility, extension, extending a base class. Now we are talking about realization or uh, realization of kind of uh, interface. Okay, so this is realization or implementing an interface. This is another form, or one interface is extending another interface. So extension, realization, again extension means it is extending more pure virtual to the interface, but this also cannot be instantiated. So extending can be interface to interface. Fourth is we derive virtually. Okay. So like I have two base classes and two base classes that derive from the same base class. So there is a base class called A and derived classes are B and C. They derive from A1 and from B and C D derives. If D wants an operation, then it will come from which path? So if this kind of confusion is there, then generally B and C they derive from a virtual. So whenever virtual inheritance comes into the picture, then V table comes into the picture because virtual, the actual realization of the virtual, the actual code that will come for the virtual is at runtime. So if it is runtime, then it will come into V table. So that much we'll talk now. So there are four kind of inheritance that we are seeing. If base class is concrete and someone wants those concrete operation in its own class, then it extends, derive from it, and anyway operation and attribute become the derived class operation attribute. It can add more. Or if base class is an interface which cannot be instantiated, then we realize or implement it, and then in a concrete class, then we implement all the pure virtual functions. Or an interface can extend an interface. So in that fashion, it can add more pure virtual function. Or a class can inherit another class virtually. In that case, the actual kind of the real actual the fixation of the base class would happen through the V table. So these are the four way of inheritance generally we see. Now question arises is why inheritance means is what is counterpart of inheritance in containment. So the counterpart of inheritance in containment is composition and delegation. Okay, so inheritance comes as a part of derived class. It cannot be thrown away. The way composition cannot be thrown away. If I have a composed class, it becomes part of the like a lifetime dependency, part of the container class. It will not go away. If container class vanishes, then contained composed class also vanishes. If derived class vanishes, the base class that is inside it also vanishes. So we can say the counterpart of inheritance in containment is composition. Okay, and then why inheritance and why containment? What is the best part of a containment? So containment is polymorph in the sense I can keep like B contains A, then A instead of A I can say B contain I point. Okay. Now through I we have so many classes derived. This is polymorph. A and then A1, A2, A3, A4, A100. A100 from A1 again A11, A12. There are 1000 classes that derive from I. If B keeps the I pointer, then at runtime it can assign any composed object based upon the I pointer. This was polymorphic containment provides. So containment may not. So if we think about composition, then it also makes it bulky because you are getting the object, but you can get the object at runtime also. So I mean, if someone has a kind of hot ice here, then I would say you can go for aggregation. Now it's all right. Where that is also a form of containment, where we can do the containment at runtime. So that is the beneficial for a containment. But what is the worst part of containment is that if someone wants all the features, all the functions of contained object, then either it can return the contained object, once you take it. B contains A, then take the A and you can call your function from the A. Or if A has 1000 function and somehow it cannot return A like in facet design pattern, then it has to delegate all operations. If A has 100 operation and client wants to call 100 operation of A through B, B contains A, then B has to provide wrapper for all 100 classes functions. Then it would delegate all the function called against the A call. That is the worst part of the containment. If someone is looking for delegation, so or you return the A, if you return the A, then client gets the A, then he can call the function. But that probably in facet kind of design pattern where the heavyweight containment is going on, probably no one would return it, and complex and those kind of. Then you provide delegation. So that is one thing. But as far as runtime assignment is concerned, that is polymorphic. So if I have I pointer as contained object, then I can have infinite number of objects that I can assign to I at runtime. I can kick out, I can bring in. So that much polymorphism inheritance cannot be. Inheritance is a very similar to composition where you inherit a class, you cannot inherit kind of this in a polymorphic way. If you inherit a class, the class functions comes inside you and that sticks with you. You become bulky and a class size grows because it has a parent class also, base class also inside it. So that is a concern. So it's a static. So inheritance is a kind of a static like composition, but it does not require any delegation. So when all the operations, so suppose the I pointer has 500 operations, all 500 operation becomes operation of derived classes. So client believe that all these functions were written by the derived class. Then he can call those functions again derived classes. It is as good as the derived class has written it. So the delegation is headache for containment, where delegation is boon for inheritance. Polymorphism is a kind of a boon for containment, whereas it is a kind of salty for inheritance. So these are the pro and cons, boon and bane for the kind of inheritance and containment. So anyway, idea is not to learn only what are the kind of how we can use inheritance. Idea is also that how many inheritance are possible and what are the features are there. Then someone any depending upon if someone is looking for designing, so he can see the containment and inheritance. And now if he knows pros and cons and all the hooks and crooks, then he should be in best position to think about that where he should do what. So that is idea behind inheritance, four type of inheritance: extension, realization, extending interface to interface, and then virtual inheritance.